Okay, so our next lesson that we're going to do in preparation for double replacement reactions is solubility rules. Okay, so solubility determines how well something dissolves in another substance. So pretty much when we talk about solubility, we're going to talk about it in water. Okay, so this chart's going to be super useful for you. Okay, so this is how we correctly read it. So in the top chart, portion of the chart, we're going to write all compounds containing blank are soluble except, okay? So that's what we have to tell ourselves every single time we're looking at the top chart. The bottom chart, we're going to say all compounds containing blank are insoluble except, okay, and our exceptions to our rules are over here. Okay, so it's better to do by example, so we're gonna look at the example problems at the bottom. Now, one thing to note, if you see AQ, that stands for aqueous. That means it's going to be soluble. If you see the symbol S, that means it's going to be a solid and it's going to be insoluble. Okay? That's when a precipitate is formed. Now, do not confuse S for soluble. That's not how it works. So if you want to write S for solid, that's fine, or you can write out the whole word. When we get into double replacement, we'll actually use the symbols a little more. Okay, so first example, we're going to look at the back ion, and we're going to say to ourselves, all compounds containing chlorine are soluble except for, now we're going to go to our exceptions for chlorine, silver, mercury, and lead. Okay, is sodium one of those exceptions? And you're going to say no, because it's not silver, mercury, or lead. So this is going to be soluble. Next one, I. All compounds containing I are soluble except silver, mercury, lead. Is the front ion one of those exceptions? In this case, it is. So you're going to say insoluble. Okay. SO4, sulfate. All compounds containing sulfate are soluble except for strontium, barium, mercury, and lead. So barium falls into one of those exceptions, so it's insoluble. Okay, next example, CO3. All compounds containing CO3 are insoluble except for, okay, our exceptions are NH4, alkali metals are group 1. Sodium is in group 1, so it's going to be soluble. It's going to be one of the exceptions. Next one, manganese 3 hydroxide. So if you want to write the structure out, manganese is Mn, it has a +3 charge. Hydroxide is OH with a -1 charge, and we're going to crisscross. Okay, so hydroxide. All compounds containing hydroxide are insoluble except for group 1, calcium, strontium, barium. Manganese is a transition metal, so it's not any of those exceptions, so it's insoluble. Okay. Next one, lithium sulfide. Lithium is Li with a +1 charge. Sulfide is S with a -2 charge. We crisscross. Okay, so our rules for sulfide. All compounds containing sulfide are insoluble except for NH4, group 1, calcium, strontium, barium. Lithium is in group 1, and so it's going to fall into that alkali metal exception. So this is going to be soluble. Okay? Now, if we want to go through and write AQ, S, S, AQ next to it, S, and AQ. Like that. So I'm in the habit of doing that. Okay, ammonium is NH4 with a +1 charge. Phosphate is PO4 with a -3 charge. We crisscross, write it like that. Okay, if it's a polyatomic ion, we have to keep it together. So the rules for phosphates: all compounds containing phosphate are insoluble except for NH4 in group 1. This falls into one of the exceptions, so it's soluble. Okay. Strontium sulfate. Strontium is SR with a +2 charge. Sulfate is SO4 with a -2 charge. So we don't have to crisscross anything because they're equal and opposite charges. So your rules for sulfate: all compounds containing sulfate are soluble except for strontium, barium, mercury, and lead. Strontium is one of those exceptions, so it's insoluble. So write S next to it. And the last one, mercury is Hg with a +2 charge. Bromide is Br with a -1 charge. We crisscross, it looks like that. So your rules for bromides: all compounds containing bromine are soluble except for silver, mercury, or lead. So mercury falls into one of those exceptions, so it's going to be insoluble. Okay, so hopefully this little lesson helped you out a little bit before we go on to double replacement reactions. Thanks.